So the do now for this lesson is asking us to write a proof given the following information. AD bisects BC. So again, our keyword here is bisects. So we're creating two congruent segments out of BC. So I labeled BD and DC as congruent. Then I know that AD is perpendicular to BC. So there are two right angles. So I know that these two angles are going to be congruent. So I have a side and an angle, and because there is a shared side between these two triangles, I'm going to use reflexive to state that AD is congruent to AD. This is how we write it out. Start with your given information as always, and then we start with our first given. Because AD bisects, we can say that BD is congruent to DC by the definition of a bisector. Because of our second given, we have perpendicular lines, therefore we have right angles, and we know that all right angles are congruent, so we can state that the two angles are congruent. We need one last side, so we state that AD is congruent to AD by reflexive, and then I am left with side, angle, side, and I can say that the triangles are congruent. Now, what we're going to be talking about today is some angle relationships that can help us solve some proofs. So if we look right here, right, these two angles are what we call supplementary angles. You might remember this from previous classes. If you remember the trick of supplementary, they add up to 180 degrees. The S kind of turns into an 8. So if you were to figure out what this missing angle would be, it would be 180 minus 30, which gives us 150 degrees. Why is it 180 degrees? Because when we're dealing with a straight line, there is 180 degrees in every straight line. So again, these are supplementary angles. So angle 1 and 2 are supplementary because they are linear pairs. The word line is in linear because they form a line. So now if you look here, there are two pairs of supplementary angles. We have angles 1 and 3 are supplementary, as well as angles 2 and 4. Now, if angle 1 and angle 2 were both 30 degrees, then we would know that their supplements would be the same because both pairs would have to add up to 180 degrees. Angle 1 plus angle 3 would have to equal 180. 30 plus angle 3 equals 180. So you're left with angle 3 is equal to 150. The same would be true for angle 2 and angle 4. And you'll be left with angle 4 is equal to 150. Therefore, the statement that we can use in our proofs, the supplements of congruent angles are also congruent. So in this case, our congruent angles had been angles 1 and 2. Angles 3 and 4 were the supplements of those congruent angles. And because of this, we can say that angle 3 is congruent to angle 4. This is the line of reasoning that we will use in some of these proofs, such as below. So, given BC is perpendicular to CD, we have a right angle. AB is perpendicular to AD, another right angle. So we have two angles so far. And we know that angle 1 is equal to angle 2. Now, angle 1 and angle 2 are not in the triangles, which is why we need to know that the supplements of congruent angles are congruent, because we know that angle 1 and 3 are supplements, and angles 2 and 4. So because angles 1 and 2 are congruent, we then know that angles 3 and 4 are also congruent. So we have an angle, and then we're going to use reflexive to state that BD is congruent to itself. If you're confused by this logic, go back to our example that we did up here. So now when we write it out, we always start with our given information. Since I have perpendicular lines, I know that there are right angles, and I know that all right angles are congruent, so I have my first pair of congruent angles. I'm going to state that BD is congruent to BD by reflexive. Then I'm first going to say that I have two pairs of supplementary angles. And then because of this, I am going to state that the angle 3 is congruent to angle 4 because supplements of congruent angles are congruent. I then have a congruent angle, and a congruent side. So I can say that the triangles are congruent by angle, angle, side. Remember, you can't do angle, side, angle. It is angle, angle, side, because the side is not in between the two angles. If it was angle, side, angle, it would have to be these two. But we are talking about the one across. So we talked about supplementary. Here we can see that we're dealing with a right angle, and that there's a relationship that these two angles are going to have to add up to 90 degrees. So if this angle is 40, the other one is 50. This is a pair of complementary angles. Similar to how I showed you the trick for supplementary, complementary you can turn into a 90 degrees. So by the same logic that we had before, we're going to say that if two angles are congruent, then their supplements must also their complements must also be congruent. So that's something else that you can use. The supplementary angles are usually more often found because it's easier to sort of draw a diagram with this, but it is also important to know that you could also need it for complementary angles as well. So here we're given perpendicular, so we have a pair of right angles. Angle 1 is complementary to angle 3. Angle 2 is complementary to angle 3. So because we know that angle 3 is congruent to itself by reflexive, and since these are both complements, we can say that angle 1 is congruent to angle 2. And then we will use reflexive. So this one's a little bit tricky because it's hard to sort of map out. But basically what we're saying, right, is we said that the complements of congruent angles are also congruent, right? So for example, let's say that angle 3 was 30 degrees. It's not, we don't know what it is, but let's just give a hypothetical, right? So then if I was going to figure out angle 1 and angle 3 have to add up to 90 degrees. So angle 1 would have to be 60 degrees. They're saying that angle 2 is also complementary. There's no other number that will add up to 90 degrees, so angle 2 would also have to be 60 degrees. Therefore, angle 1 is congruent to angle 2. And we can derive that by saying that angle 3 is congruent to angle 3. Use the given statements to state angle 1 is congruent to angle 2. So first, as always, we write our given statements. I'm going to use the reflexive for two properties here. I'm doing CD to get our side in between our angles, as well as angle 3 is congruent to angle 3. I'm stating that I have a pair of right angles based off of the definition of perpendicular lines. I'm then stating that those right angles are congruent. And then I'm going to state that angle 1 is congruent to angle 2 because complements of congruent angles are congruent. Since angle 3 is congruent to angle 3, we can use this relationship. And now I am left with stating that the triangles are congruent because I have angle, side, angle. For the next one, we're given that BD bisects angle CBA. So I have two congruent angles here. That's one of the things I'm going to have to write. There's a shared side, so I know I'm going to want to use reflexive. And then I know that angle 1 is congruent to angle 2. And it's very similar to the diagram we had before. There is a straight line. So I know that there has to be a supplement relationship. So I know that these two angles right here are going to have to be congruent because they are the supplements of congruent angles. So how do we write this out? Start with our given statements. I'm going to start with reflexive. I state that BD is congruent to itself to get that side. I'm going to state that CBD is congruent to DBA. It actually should be the other way around. It should be ABD by the definition of a bisector. I'm then going to state that there is a supplementary relationship between my pairs. Because of this, I can state that the two angles, the two purple angles here, are complementary, congruent, because the supplement of a congruent angles are congruent. And now if I label this, I have an angle, a side, and an angle. So the triangles are congruent by angle, side, angle.